Module 1, Fundamentals of Computers and Networking Basics. Lecture 1, Introduction to Computers. Welcome to the course Introduction to Computer Networking. Before we delve into networking, it is essential to understand the basics of computers. A computer is an electronic device designed to process data and perform tasks according to a set of instructions. Computers consist of hardware and software. Hardware refers to the physical components such as the processor, memory, motherboard, input and output devices, and storage. Software refers to programs and operating systems that instruct the hardware on how to operate. The organization of a computer typically includes the central processing unit, CPU, memory units, input, output devices, and storage. The CPU is the brain of the computer, responsible for executing instructions. Memory units store data temporarily or permanently. Input devices like keyboards and mice allow users to communicate with the computer, while output devices like monitors and printers provide feedback. Understanding hardware and software is crucial because networking involves configuring both physical devices and software settings to enable communication. Lecture 2, Basic Networking Concepts. Networking allows multiple computers and devices to communicate and share resources such as files, printers, or internet connections. Key terms include network, a collection of computers and devices connected to share resources. Node, any device connected to a network. Protocol, a set of rules that governs how data is transmitted. Bandwidth, the amount of data that can be transmitted in a given time. Network topologies define the layout or arrangement of network devices. Common topologies include LAN, local area network, a network within a small geographic area, such as an office or school. WAN, wide area network, a network that spans large distances, often connecting multiple LANs. MAN, metropolitan area network, a network covering a city or large campus. PAN, personal area network, a small network around an individual, like Bluetooth devices. CAN, campus area network, a network connecting multiple buildings within a campus. Lecture 3, Networking Models, OSI and TCP/IP. Networking models provide frameworks to understand and implement communication protocols. OSI model, Open Systems Interconnection, has 7 layers. Physical layer, transmission of raw bits over a physical medium. Data link layer, error detection and framing, controls how data is placed on the medium. Network layer, routing of data between devices across networks. Transport layer, ensures data delivery, error recovery, and flow control. Session layer, manages sessions and dialogues between applications. Presentation layer, translates data formats and encryption. Application layer, provides network services directly to user applications. TCP/IP model is a practical model widely used in networking with 4 layers. Network interface corresponds to OSI's physical and data link layers. Internet layer, responsible for addressing and routing. Transport layer, provides end-to-end communication. Application layer, handles protocols like HTTP, FTP, and SMTP. Understanding these models is critical for designing, troubleshooting, and implementing networks. Lecture 4, Network Adapters and Protocols. A network adapter is hardware that connects a computer to a network. It can be wired, using Ethernet, or wireless, using Wi-Fi. Protocols define how data is transmitted and interpreted. Common protocols include HTTP/HTTPS, used for web communication. FTP, for file transfer. SMTP/IMAP/POP3, for email transmission and retrieval. TCP/IP, the fundamental protocol for Internet communication. Protocols ensure that devices from different manufacturers can communicate efficiently. Lecture 5, Cabling and Troubleshooting. Cabling is a critical part of wired networking. Types of cables include twisted pair cable, common in LANs, includes unshielded and shielded variants. Coaxial cable, used in older networks or specific broadcast applications. Fiber optic cable, high-speed, long-distance data transmission. Troubleshooting cables involves checking connectivity, signal strength, and integrity using tools like cable testers or pin test. Networking troubleshooting also includes verifying IP configurations, checking device connections, and monitoring network traffic. Lecture 6: Networking devices. Various devices are used to connect and manage networks. Routers connect different networks and direct data packets. Switches connect multiple devices within a LAN and forward data efficiently. Modems convert digital data to analog signals and vice versa for internet connectivity. Hubs, basic devices that broadcast data to all connected nodes. The choice of device depends on network size, speed, and complexity. Lecture 7: Wired and wireless technologies. Wired technologies include Ethernet, coaxial, and fiber optics, which offer high speed and reliability but limited mobility. Wireless technologies include Wi-Fi, Bluetooth, and cellular networks. Wireless allows mobility and convenience but can be susceptible to interference and security risks. Lecture 8: Inside the PC. Understanding internal PC components is important for networking. Key blocks include: motherboard, houses CPU, memory, and expansion slots. CPU processes instructions. RAM, temporary storage for running applications. Storage, hard drives or SSDs for permanent data storage. Network interface card, NIC, connects the PC to the network. Assembling and disassembling PCs safely helps in troubleshooting and upgrading networking components. In this module, we covered basics of computers, hardware, and software. Networking concepts, topologies, models, and protocols. Network devices, cabling, and wireless technology. Inside the PC and practical understanding of components. These fundamentals provide the foundation to configure, manage, and troubleshoot networks effectively.